So let us start with a very simple idea. I have a point charge Q. How many lines does it produce? Q by epsilon naught lines. How are these lines going to basically emerge? One is going to come out like that, but if I was one more line, it will definitely have to come out like this, because they try to be as far away as possible. These are lines, not arrows. Okay. Then one line will go out like that, one line will go out like this, one line will go out like that. They will try to keep as far away as possible, but do you think they'll all basically be in one plane? No, it will also come out like that, come out like this, equally spaced, right? So this, what I have drawn here should not be seen as on a plane. Think of it as a three-dimensional space. So it's going out in all directions equally. Okay, so it's coming out in all directions, right? Now, if you were at this distance, so let us say that you were at this distance, it's all equally spread. How many lines? Q by epsilon naught lines. At this distance, let us say it was r meters. What is the surface area? 4 pi r square. Now what is the density? Number of lines by? Remember, density, electric field is lines per unit area. The density of lines. How many lines? These many lines. What is the surface area? It is distributed uniformly. How do you know it is uniformly? Because they are trying to keep as far away as possible. Now if two things were not uniform, then somewhere they are too close. Somewhere they are far away, but these two lines are going to fight. Why are you so near me? Go that way. Right now, if one line is here and another line is there, this line and that line is going to push. Now if I had a third line, this guy is going to say, wait, I can't go that side because that guy is fighting with me. I can't go this side because this guy is fighting with me. So that's where I am going to remain. So think of it that way. Okay, it's like a general sharing problem, cake cutting sharing problem, right? So everybody wants it equally. So everybody fights otherwise. If it's not unfairly divided, somebody is going to argue. So it's fairly divided, that means it's uniformly spread. No particular reason that this line and that line must be close and this guy must get a lot more space. There's no reason, because this line is equal to that line. So given they are all equal, they are going to spread uniformly over how much surface area? What is the surface area of a sphere? 4 pi r square. So many lines divided by 4 pi r square. This must be the electric field at a distance r. But you already know this, Coulomb's law. Why do you get this 1 by 4 pi epsilon naught? Because actually it is 1 by epsilon naught, number of lines is q by epsilon naught, shared across 4 pi r square surface area. That's why it is 1 by 4 pi epsilon naught r square. Is that clear? Now this tells you the electric field of a point charge, Coulomb's law. Using what idea? Using the idea that charges produce lines. So Faraday derived a lot of stuff. If you think lines are not mathematical, of course they are mathematical. We are now deriving stuff using lines.
Part of the line, part of the charge is only distributed.
No, not part of the charge. Charge means it sends out lines. So if this charge sends out lines, how many lines? Q by epsilon naught. Why Q by epsilon naught? That is why it's called Q. If you are 2 coulombs, you will send out 2 by epsilon naught. If you are 1 coulomb, you will send out 1 by epsilon naught. If you are 1000 coulombs, 1000 by epsilon naught. And if you are minus 5 coulombs, you will pull in 5 by epsilon naught lines. You are plus if you send out lines, you are minus if you pull in lines. And you are Q because you send out Q by epsilon naught lines.
Which idea was found first?
Which idea was? Coulomb's law was already found. Coulomb's law was already there. But Faraday came up with the idea of lines, came up with the idea of how to calculate for a whole bunch of different things, and came up with the idea of electric field. Okay. For example, Coulomb's law does not explain why light and electricity have a connection. Faraday's idea explains that. If we extend it a little bit, it does explain that. So Faraday did a lot of stuff on electric fields, studied electric field in a very big, very important way. In fact, most of electricity, magnetism, huge chunk of it was discovered by Faraday. Okay, and so his way of thinking definitely is powerful. If it worked for Faraday, it will work for us. Okay, it is not like it doesn't do certain things like superposition, for example. It doesn't work very well. For fields, it works very well. But for lines, it's already superposed. So why do you need superposition on top since it's already superposed? Right? So this line and all, this is the net result of all of it. Superposition is to find the net result. Lines allows you to get the net result directly. So he didn't need too much of this. By the way, he also discovered electric fields as a good way of thinking. So both. We just are saying we would like to use the end product of the lines way of thinking, like this product, without using the lines way of thinking. Because lines are a little confusing if you want to actually use it. But I think it's okay to live in that danger zone. So you should keep in mind that this is not perfect. It will have problems. So take it to that limit and then not use it after that. Now every idea you can't say therefore I will not use this idea at all. So use it a little bit and then you can give up at some point. But you will find this very powerful. So it's not worthwhile saying let us not do this at all. So let's understand this a little bit. So this is okay, if it's all we are going to do is to derive Coulomb's law, then this is not a great way. I mean, you don't have to spend so much time thinking and understanding it if the only thing we want to do is to come up with Coulomb's law. But there's a whole bunch of things that we can come up with. So let us think about some of those. Okay, so what I'm going to do now is to show how this works. By the way, do you understand now why it is 1 by r square? Because it's the same number of lines, but as you go out, 4 pi r square have to share it. Okay, but it's the same number of lines. An electric field is just the number of lines by area. Area is increasing as r square, but the number of lines remains constant. So obviously, the density must come down as 1 by r square.